everyone, my name is Madison and I'm a program educator at Cornell Cooperative Extension of St. Lawrence County. This week we're going to be continuing our lessons on astronomy. Last week we learned about stellar astronomy and constellations. This week we're going to be doing a mixture of planetary astronomy and theoretical astronomy. Planetary astronomy is all about the planets and the moons and comets. Planets are celestial bodies. In order to be a planet, they have to meet 3 criteria. First, they have to orbit a star. In our solar system, our star is the sun. Second, it has to be big enough to have enough gravity to force it into a spherical shape. And third, it has to be big enough so that its gravity clears away any objects close to its size near it. We have 8 planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Pluto was once considered a planet in our solar system, but now it's considered a dwarf planet. All 8 of these planets have unique features. Mercury is the smallest and fastest planet. It gets around the sun in 88 days, which means that its year is 88 days. In comparison, the Earth's year is 365 days. Mercury is only slightly larger than the Earth's moon. Venus is the hottest planet in our solar system. It also spins in the opposite direction from all of the other planets. Earth is the only planet so far that we know of with living things. It's also the only planet in our solar system with liquid water on its surface. Mars is like one big, giant, dusty desert. There's evidence that billions of years ago, Mars was warmer and wetter and had a thicker atmosphere. This is why we're looking to see if there was ever life on Mars. Next is Jupiter. Jupiter is the biggest planet in our solar system. If we were to take all the other planets and put them together in one large mass, Jupiter would still be twice as large. Jupiter is best known for its red spot. The red spot is a storm that has been going on for hundreds of years. It's so big that it could swallow 4 Earths. Imagine a hurricane that big. They've also found, however, that the red spot is actually shrinking in size, so at some point in our lifetime, it may disappear. Saturn is best known for its icy rings. Although the other large planets in our solar system have rings, none are quite as spectacular as Saturn's. Uranus spins at a 90-degree angle from its orbital plane. Therefore, it looks to be spinning on its side. Neptune is the 8th and farthest planet from the sun. Because it's so far from the sun, it's cold and icy. It's also very dark. At one point, Neptune also had a storm, but it's now disappeared. Neptune was the first planet to be located through mathematical calculations. Neptune is also whipped by supersonic winds. Theoretical astronomy is all about using math and calculations to help us better understand outer space. Today we're going to be learning about the planets in our solar system and drawing them to scale. Although our planets won't be as big as the actual planets, they will be scaled so that they are accurate to each other. We will be able to see how much bigger Jupiter is from Earth. Unfortunately, we're not going to be able to draw our sun to scale, because based on the size of the planets we're using, the sun would have to be 12 feet in diameter. Maybe if you can find a really big parking lot, you could draw it with chalk. We will also be using math to make a scaled version of the solar system. Although our planets won't be the right amount of distance apart because they're so far apart in real life, we will see how far apart they are relative to each other. It will be like a miniature version of the solar system. If we were to separate our planet drawings by the correct distance, we would have to go 7.5 miles between the sun and Neptune. That's about a 7-minute drive if we were to go 60 miles per hour. So we are going to use popsicle sticks to separate our planets, and we are going to pretend that the planets are teeny tiny. In fact, some of the planets will be so tiny that we can't even see them. The sun will be 0.03 inches. That is smaller than one little tick mark after the 0 on a ruler. And the sun is much bigger than all of the planets. If you took a mechanical pencil and you looked at the diameter of its lead, you would be able to fit Mars on it 197 times. So we're going to use our popsicle sticks and pretend. That way we only have to go a few feet in between the sun and Neptune. So let's get started. Draw a dot in the middle of a piece of paper. Use a ruler to measure the radius of the planet. Put one end of the ruler at the dot and then use a pencil to mark the correct radius. Measure the radius to the other side of the dot, the top and the bottom of the dot. It should look like this at the end of this step. Connect the marks around your dot with a circle. Once you have erased the dot in the middle, you can begin drawing any details on the planet that you would like to include. I am drawing Earth, so right now I am drawing the continents. You can also add color at this step if you would like. If you look in your written lesson plan, you will find a table that looks like this. The table has all of the planets. It also has the distance that these planets are from the Sun. This part of the table has the distance in astronomical units, or AU. Our job will be to convert this distance in AU to a distance in inches or feet. We're going to do this using a proportion. Let's start with Mercury. For all of these conversions, we're going to say that 1 astronomical unit is equal to 4 inches. The first step is to set up the proportion. 1 AU is to 4 inches. .4 AU is equivalent to how many inches? We're going to use a variable here, since that's what we're trying to figure out. We are now going to cross multiply. We now have 1x equals 4 times 4 is 16. 4 times 0 is 0. Add the 1, you get 1. Since one of our numbers had a decimal point, we have to look at how many places over our decimal point was. This is the only number with a decimal point, and it is 1 over. So we're going to put our decimal point 1 over. To get x by itself, we have to divide it by 1. So 0.4 astronomical units is equivalent to 1.6 inches. So now we can add it to our table. Let's try it with Neptune now. Again, 1 AU equals 4 inches. Our first step is to set up the proportion. 1 AU is equivalent to 4 inches. .1 AU is equivalent to how many inches? We will now cross multiply. One x equals 30.1 times 4. 4 times 1 is 4. 4 times 0 is 0. And 4 times 3 is 12. This is the only number that has a decimal point, and it's over 1 space. So we're going to put a decimal point 1 space. We're now going to come back over here. We will write 120.4. To get x by itself, we have to divide both sides by 1. X equals 120.4. So now we can come up here to our table. 120.4 inches. 120.4 inches is sort of a lot. It might be easier for us to use feet when we actually put together our scaled solar system. So we should now convert 120.4 inches into feet. 1 foot is equivalent to 12 inches. How many feet is equivalent to 120.4 inches? We cross multiply, and we get 12x equals 120.4 inches. To get x by itself, we have to divide by 12 on both sides. Twelve goes into 12 one time. 12 times 1 is 12. Now we subtract. 12 goes into 0 times. 12 times 0 is 0. At this point, we want to add our decimal point up here so that it lines up with the way the decimal point was inside. 12 goes into 4 0 times. 12 times 0 is 0. 4 minus 0 is 4. At this point, we want to add another 0 here so we can drop it down. 12 goes into 40 3 times. This is enough places for us to go, so we can just use this as our final number. Therefore, we can say that is 10.03 feet. So now we can add 120.4 inches slash 10.03 feet to our table. Your job now is to make the same calculations for these planets. Once that is done, you can make your own solar system with all of the planets spaced out to scale. You will just need to find a space big enough so that Neptune can be 10.03 feet from your sun. There's a really great video on YouTube that you can watch. In the video, they talk about how there are no actual scale drawings of the solar system. These two friends wanted to make a model of the solar system that was scaled. In their model, the Earth was the size of a marble, and the sun was a little over a meter in diameter. Because they were in Nevada, where there's big, wide open space, they were able to go 7 miles to make sure that the planets were scaled to the right size and the right distance. We didn't have space like that here in the North Country, so we made a smaller version where the planets were microscopic. This video will allow you to see what it would look like if the Earth was the size of a marble. To find the video, you can either visit the link that's here on this page, or you can go to YouTube and search "to scale the solar system." Thank you so much for exploring planetary and theoretical astronomy with me today. I am very interested in seeing all of your planet drawings, so if you'd like to share them with me, you can email me at mpo34@cornell.edu. Bye!